All right, so calculus, the first lesson we're going to talk about is finding limits. But before we do that, we just have to talk about what is calculus, right? Some of you was like, what is calculus? What does that mean? Calculus is the, if you look at this one, why mine is not connecting? Okay, it's like a process. It's talk about the changes, the rate of change. So we talk about rate of change in algebra. We talk about rate of change in calculus. But it's really, if you look at this one, right? Think about algebra. When we talk about rate of change, we also talk about slope of a line. So that's one thing. So in algebra, the difference, so you can kind of give you an idea what's the difference between calculus and any other math that you took earlier. So slope of the line, remember when we have rise over run. That is what we normally learn, right? Slope of the line, we find the change in the y values over the change in the x values. So that's what we look in, right? However, in calculus, we not only look at a straight line. So that's the difference. We look at the slope of a curve. So that's one thing that is different than, what am I doing? Okay, so that's just one thing that is different than what we learn in, oh, sorry. Now I cannot see my screen. Sorry. This, how do I go back? Okay. There you go. Okay, I see it now. Please be patient with me. I forgot how to do this. I hate conference, and now I wish we can use conference. Okay, trying to figure out. Okay, I think I got it. Sorry. Okay, so slope of the line, when we talk about straight line, but we not always will run into a straight line, right? We will run into function. It's not going to be a straight line. It's going to be a curve. The same thing that if we talk about the rate of change, like if you learn in, we talk about area. If we talk about geometry, we talk about area, right? We know how to find area of a rectangle, of a square, of a circle. But in calculus, we not only talk about like a solid shape, we talk about area under a curve. So it's more complicated. So we need to find a way to do that. Because now I'm like, what is this shape? It doesn't look like, it's kind of sort of like a rectangle. It looks like a trapezoid. It may not, right? So we have to figure out another way to learn how to find the area. So that's the difference. Another thing that we talk about the average rate of change. We also talk about, if you think about driving, right? We so often was like, okay, so-and-so driving 30 miles per hour. He's driving 30 minutes. What is the distance? But the question in real life is, you're actually going to drive, let's say you're going to travel, you're not going to drive the same speed for 3 hours, even within 30 minutes. You're going to speed up somewhere, you're going to slow down somewhere, right? So that is the part where it's talk about calculus, is that we're not going to find the average, we're not going to talk about the rate of change for the entire trip. We talk about the rate of change at a specific time. So that's the instantaneous rate of change. That is mean, the question is, how fast are you traveling at 12 o'clock? How fast are you traveling at 12:05? And that's the difference between calculus and algebra or pre-cal, right? The other one, they just give you one rate, and that was it. So you're like, okay, I'm going to drive 60 miles per hour. I'm going to do it for 3 hours. No way, right? It's impossible. You're going to run to a red light. You're going to make a stop. You're going to slow down. You're going to speed up. So that's not in reality. So that's the calculus part. The rate is not going to be the same. We're going to still talk about the slope. we'll still talk about rate of change, but now we're going to be a little bit more specific. Okay, we can think about the travel time. We travel from 6 a.m. until noon. So we can talk about at 9:05, how fast you travel, how far have you been traveled with that function. Okay, so that's the difference between calculus and pre-cal or algebra 2. And then let's take another. So we talk about secant line, which is you find the slope, you choose 2 points, and you find the average. But that's not the case in calculus. You can have a curve, and we should be able to find the slope at a specific point, as the specific values. Also, in pre-cal, you should be able to evaluate a point if it's a solid point, right? You can say, okay, at 3, the y value is 5 or something. You plug it in, you should be able to evaluate. And then you run into some problem where you have a hole, like if you look over here, that is mean it's undefined. When it's undefined, you plug it in, it tells you it's an arrow, and you don't know what that value is. And that is something that we can use calculus to figure out what is that values. We call it limit, and that's the one that we're going to look at today. The limit. We get closer and closer to that point. Another thing we talk about is like surface area. We know a cylinder. We know how to find surface area of those, but not everything is going to be a cylinder. We have a different shape, what you do. Okay, so calculus, if you talk about, they figure out how to find the volume of a bottle or how to generate and make the bottle, right? Or the classes. So the different shape, different function, and they'll figure that out. Okay, so those are things that we'll look at in calculus, right? So any questions, concerns so far? And what we're going to focus on for today is this one, to find the limit when it's approached a given point. All right, so let's look at this one, okay? Limit approach at a given point. So if you look at this function, now this is a function, look like a quadratic function. What happened at 1, when x is 1, if you look at this point? What do you see? What happened at that point? It's undefined, okay. So when it's undefined, that means there is a hole. And what happened is, if you evaluate f of 1, that means you plug it in, 1 minus 1 is, that's going to be 0 over 0, right? So that's a problem. I don't know what that value is. It's undefined. Yes, so that's what it means undefined, because when you plug into the calculator, it will say error. It will not be able to, when you plug it in, you don't know. So that's one thing. Good. It's undefined. However, there is a way for us to figure it out. It's called the limit approach. So in calculus, we want to figure out what happened. So think about why we care about what happened at this point by using the limit approach is that, as I talked to you earlier, I shared with you, is that when we do when we find the slope, if there is a straight line, this is pre-cal, this is algebra 2, we find the slope when we have a straight line. But now we're going to focus, and function is no longer a straight line. We look at the curve, and that's what we want to focus. And the limit is that the approach that we're going to figure out. So what the limit, what I really want to do at this point is that I want to find the slope. I want to find the slope at this point. I can't even draw it. I want to find the slope at this point. Okay. So my goal is to find the slope at that given point. So I'm going to use the limit approach to find what is the slope at that point. Later on, we can find what is the slope at this given point. what is the slope of this point or this point at the bottom? Okay, so those are the things that we want to focus on. That is what we're going to do for the next couple of days. We're going to need a calculator. We're going to need, if you don't have graphing calculator, we can use decimal. Are we familiar with decimal? At least for this one. But any other things, we definitely need a calculator. So for now, I found a way for you to do it if you don't have a graphing calculator yet, not until Thursday. So we can use decimal, okay? So limit, approach, what we're gonna do, what I want you to focus and think about, we'll come back and finish this next time. We will talk about how we're gonna do it. But limit, what we're gonna focus on today and the next few days is we're gonna find the slope of a curve, a slope at a specific point. Because think about this, if I'm going to draw a line, look at this slope. It's positive. But if I'm going to choose a different point on this graph, let's say if I'm choosing this point right here, the slope, if you draw, I estimate when I draw that line, look at the slope on that side, it's kind of sort of like it's negative slope, right? So it changed. They don't have the same slope. It's like kind of negative, and then the slope is go back up, which is the same thing like when you drive in, right? Sometimes we slow down, we make a stop, and then when the green light turns, then I'm gonna speed up again. So those are the things that give you an idea. It's change. The rate is changing. Okay, and then over here, I want some of you to start thinking about what is the slope for this point right here, all the way in the bottom at the vertex. What should be that slope? Okay, so if this one is seem like go down, that's negative slope. This seem like positive slope. What is the slope for the point on the bottom? Can someone tell me if you have to guess? What should be the slope right here? You can unmute, you can put in the chat. Doesn't matter. What do you guys think? 0? Okay. Yes, it's 0. It's horizontal. If look at the line that I draw, it's a horizontal line. The slope is 0. So as you can see, you have one function. The slope is not the same. I make a general cases is over here is negative, over here is positive. But again, when you have positive, some of the slope can be a little bit bigger or smaller, depending on the points. So that's what we're going to look at next time, okay? So for today, 2 things. Yes, it's 0 because it's neither go up or down. It's going across. That's the constant speed. If you can think about this, it's like you say the same speed. You're not speeding up, you're not slowing down. You're in the same speed. Okay, so 2 things you want to complete today is the bio poem and join Khan Academy. Some of you told me you cannot. I will try to share the link again, see if that works. We'll come back to this note when I see you next time, which is Wednesday, okay? It's 8:50. Thank you. Have a good day. I'll see you next time, okay? Bye, everyone.